processes and applications for auto, truck, and industrial markets. Prior to joining INEOS, he held a variety of technical, commercial, and management positions with General Motors, Cambridge Industries, Meridian Automotive Systems, and Continental Structural Plastics, CSP. Dan has a bachelor's, an ME from Michigan State. Congratulations, Michigan State. I'm over for you.
Good school.
He has an MBA from Wayne State University and has participated in nearly every ACCE as a speaker, exhibitor, or a session organizer and moderator. Dan?
Everyone still see me? Well, thanks for that nice introduction. Thanks, Leo and the SPE organizing committee for putting this session on. Really appreciate being invited to be a part of it this year. I think it's sometimes important to start these with a story, so I'd like to do that as well. 3 composite engineers, a monkey, and a purchasing agent walked into a bar. I'm not going to tell that story. But I do have a story more closer to our theme. So when I got into this industry, short 35 years ago, I joined General Motors. General Motors at that time, of course, of the Corvette, but they had a whole line of composite intensive vehicles in the pipeline. The Fiero, the APV minivans, some Cadillac sedans. They had in-house molding. They had tech centers. They had a group that I was a part of actually was looking at how to convert the Fisher body stamping plants to SMC compression molding plants. So I was young, dumb, and naive, but I was absolutely convinced composites were going to take over the world. So now let's fast forward to today. I'm still dumb and naive, but I'm old now. Composites did not take over the world. We've made strong, steady progress. We've got a rock-solid value proposition in saving mass, reducing corrosion, reducing NVH, part consolidation, everybody in this room probably knows that by heart. But there's some obstacles we've really not completely overcome for high-volume applications. And if we say 1, 2, 3, let's all say it together, it's cost. Certainly, the OEMs, the automakers, they have a lot of pressure on them. They're very good at finding the low-cost solution for their applications and their vehicles. Sometimes it takes a couple of iterations, but they always get there. Composites has some work to do in this area, and that's why driving value is a great theme for this year's conference, just as the automotive industry is making some real radical changes as well. So I'm going to start with a couple words about the company I work for, INEOS Composites, and then we'll jump right into our theme, driving value with composites. INEOS Composites is a part of INEOS, our parent company. It's one of the world's largest chemical companies. They're UK-based, over $60 billion in sales, 168 sites, 22,000 people, 22,000 associates. People may have heard of INEOS in a couple different forms, at least relative to the automotive world. A new company called INEOS Automotive actually is launching a new vehicle next year in Germany called the INEOS Grenadier. It's going to be a 4x4 SUV modeled after the original Land Rover Defender. Really exciting vehicle, and people worldwide might hear our name a little bit more next year. Specific to the automotive supply world, a couple other business units, INEOS Styrolution, folks might have heard of for a wide range of styrenic materials. INEOS Olefin and Polymers, likewise a range of thermoplastic materials. And then INEOS Composites, which is our group. So INEOS Composites, again, we used to be Ashland Composites until 2 years ago. We're based in Dublin, Ohio, approximately $1 billion in sales, 20 plants, over 1,000 people. And you can see a along the bottom what our focus is on a business. So we are in thermoset resins, specifically polyesters and vinyl esters, also do gel coats and a wide range of additives, supporting just about all the acronyms in our industry: compression molding and injection molding, infusion, RTM, pre-breaks, pultrusion, just about every process using thermoset composites. We try to support that with our materials. And again, in a lot of industries, including transportation, we're all here for today. Our specific products are designed for a wide range of both chemistries as well as end properties, depending on what our customer or the end customer needs as far as performance on the end application. You can see examples here whether very high mechanical properties, strengths and stiffness are required. In some applications, folks want a low odor matrix for their composite system. We have systems that support carbon fiber as well as reduced density systems and some sustainable materials. Thanks to the courage and creativity of the OEMs and the hard work by our direct customers, which are the compounders and molders for the automotive industry, INEOS resins have ended up on some pretty exciting applications. This is just a handful of examples, starting in the upper left there, the Hyundai Santa Cruz pickup bed, which is launching just this summer. Great application for thermoset composites, and there's some on display here. Folks can take a look at it. Really exciting application of the materials. Certainly some of our resins end up on the exterior of the Corvette. Ford F-150 tailgate surface, again, a good application of a molding color, high strength, impact resistant composite. Along the bottom, you see the Stellantis Tyrannosaurus Rex front fender, good exterior application. A battery box from the General Motors, which we're going to talk about more, a really exciting new application for composites. And then our materials, fortunately, are used across the board on a lot of heavy truck applications. Navistar is shown, but we certainly also support PACCAR and Freightliner and Volvo, etc. Composites have been used in that industry for a long time for hoods, roofs, fenders, doors, etc. So that's a quick commercial on who we are. Now we'll get to our theme, driving value with composites. And I know it's early in the morning, and some folks have only had one cup of coffee so far, but I think it's important we start with a little bit of math. I'll give you a second on this. I'm sorry, this is the wrong slide. Okay. Maybe this is more our speed this morning. So, we're here to talk about driving value. What can we do to increase value? This is a real simplistic variation of that equation, which is an overstatement. The true VAVE and TCM junkies know it's a lot more complicated than this, but for the next 10 minutes, let's go with this and talk specifically what can composites do to increase the numerator and decrease the denominator. So if we peel it apart a little bit, and we'll look at some examples of where composite materials can help with both sides of this relationship. Again, the top side, what can we do to increase the functions, increase the performance, increase customer satisfaction? And customer satisfaction is the important part as you go through these brainstormings or you think this. So try to put yourself in the position of the individual who's going to buy and drive that vehicle. They don't care that you reduce the specific gravity from 1.9 to 1.3, but they do care that they're going to get a little bit better fuel economy. They don't care what the glass content is in their tailgate, but they do care that they can drop a cinder block on it and it doesn't crack, it doesn't break. They do care certainly about the denominator as well. Everything we can do to reduce the cost of that vehicle, either purchasing it or operating it, is appreciated. So that's where we start. So let's look at a couple of examples the composites industry has done to work on both sides of this relationship. Starting with one of our favorites, which is pickup truck beds, boxes, stowage systems. There's a lot out there by some of the big OEMs, and there's some new ones launching this year. It's really a good application for composite materials. So again, the top half of the relationship, what can composites do in this area to increase the function, increase the performance? And this one's really a slam dunk. If you look at the integration that composites enable for pickup beds, halo dividers, lockable stowage, spare tire packaging, tie downs, tool pockets, seals, telescopic bed extenders, anti-slip surfaces, molded in logos. It's a really long list of things that composites can do that really bring value to the end customer that other materials can't do. Additional improvements include things like handling and fuel economy, which we gain through mass reduction, and then extended durability. You won't see any of these vehicles rusting out or sitting on the side of the road. Fantastic durability with the composite materials in a really rough environment. From the cost side, it's not always a slam dunk. So I think when we go head to head with sheet metal stampings or aluminum stampings, composites typically do have a higher variable cost. Lower tooling cost, but higher variable costs. So again, that's an area of continued focus by our industries, by material suppliers, the molders, everybody in the entire chain. How do we keep driving costs down to make it more attractive for the automakers to use our materials? But there are some very specific cost saves when you use these materials as listed there, particularly in the case when you're using one of these mold color composite materials that are UV stable. They do not require paint, they do not require a spray-on bed liner, they do not require a drop-in bed liner. So really providing a cost reduction or a cost save for the end consumer. Additionally, for both the consumer and the OEMs, drastically reduce warranty costs we've seen on the applications that have been in the field now for over 10 years. Just not seeing the customer dissatisfaction claims about dings, dents, scratches, corrosion, etc. So this is maybe a good example, a good model on the type of applications where composites fit and can really drive value for the end consumer. There's been a lot of structural and semi-structural applications as well in composite materials. Have a couple favorite examples here. This is the old fender supports on the Dodge Viper. This is a really exciting project that Magna and Ford did a couple years ago. There were a lot of papers here at this conference on a carbon fiber SMC subframe. And likewise, it's been used on a variety of bumper systems, integrated front-end modules. That's an instrument panel support. So for structural applications, it's maybe a little bit more challenging, at least with the traditional high-volume materials, but we do have some advantages to build on. From the increasing the function, increasing the performance side, certainly all these applications result in significant mass reduction, which will improve the vehicle handling, fuel economy again. And a lot of applications, they have some inherent NVH advantages resulting in a quieter ride or quieter passenger compartment. Reducing costs, again, this is a challenge we still got to look at hard. In every one of these applications, the composite solution did have higher variable costs than a comparable metallic option. But there are some advantages. We see these applications are usually able to consolidate parts, take lots of stampings and brackets and fasteners and locators and mold it in, or at least co-mold it in or adhere it to the composite part. So greatly simplifying that part of the supply chain and actually putting the component on the vehicle saves the OEM some costs. And again, something relatively new to certainly the automotive industry and our industry as well, electric vehicle battery enclosures. This is starting to grow. Composites are getting great traction in this industry. I think there's going to be a lot of discussions about it during the session this week. So where do composites fit and how can they actually provide some value to the consumer, the end consumer? For the top half of the relationship, certainly improve vehicle handling and range. For these large, difficult products, we're going to save a lot of mass over comparable metallic components. Again, some NVH advantages that might result in a quieter ride, and safety. Certainly don't need to get into a lot of the bad press that some of the pioneers have got to with using some of these battery cells, but there's things we can either mold into it with the material or add to the molded component to improve the flame resistance, smoke resistance, and strength of the material for side impact. How about the cost side of it? Is there some advantages? And I think the answer on this one is mostly yes. For very large, complex, deep draw parts, which a lot of these covers and carriers are, composites can actually have a lower variable cost. They're also able to integrate a lot of other features and functions, RFI, EMI, heat shields, seals, logos, warnings, attachments, reinforcements. These are pretty complicated systems once they're all fully assembled. And we put as many of the functions and features onto the carrier itself to drive the total cost down. Another potential advantages as they're looking at the thermal management of these battery cells. You don't want them too cool, you don't want them too hot. Composites are naturally good insulators, so if there is an active heating and cooling system, this can act as your cooler, as your insulation block, and hopefully simplify the heating cooling system and reduce costs. A couple other new areas that are going to get a lot of talk about this week, certainly again a little more on electric vehicles, hybrid vehicles. There's applications on those vehicles that didn't exist. Frunks, a word I didn't know what it meant 2 or 3 years ago, or front trunks. So as the powertrains are drastically changing, it's opening up new areas for stowage, including the fronts, rears, sides, etc. Composites are a good fit here as they're able to integrate a lot of those functions, and again, with low-cost tooling for large, deep-draw parts. An area where folks are starting to look at is the actual charging stations. These are going to be ending up lots and lots of places. They don't move, it's not a vehicle, but certainly it's part of our industry. And here again, the composite materials have some advantages, at least for the frames and covers, based on our toughness, our ability to sustain exterior environments. And then in autonomous and connected vehicles, likewise, composite materials are finding a fit in mostly in exterior and some semi-structural applications where the value is being able to embed or mold in or integrate sensors and circuitry, transmitters, antennas, a lot of things that metallic materials just would not be appropriate for. A couple other strategies to reduce costs, so now we're looking at the bottom half of the equation, is design optimization, which certainly is an old topic, but we need to educate ourselves and educate the OEMs. There are some very specific strategies that you can use with composites to optimize the design that aren't as commonly used on metallic materials. Maybe it's old news for everybody in this room, but something like part thicknesses. If you're going to stamp a body panel with 0.8 millimeter sheet metal, pretty much that whole panel is going to be 0.8 millimeters thick. In composite materials, you can vary the thickness. You can be 3 millimeters where you have high stress, high loads, attachment points, but then you can thin it down to lower thicknesses elsewhere. So again, driving the mass down and driving the cost down. A fairly new area is not CAE tools, but the ability folks are starting to look at as we add different types of reinforcement systems, continuous glass, unidirectional glass, woven glass, carbon fibers, aramids, or even metallic inserts. We can very selectively engineer those products to minimize the cost. Only put the reinforcements where you need them and in the direction you need them. Again, it's a way to reduce mass, reduce costs. And then of course, the mantra from the design side, integrate, consolidate, eliminate. The best engineered part is no part at all, which isn't good for us, but the point is integrate as many functions and reduce the number of total parts, and that's a good fit for composites. Lastly, you got to talk about material costs. Certainly at INEOS, we take the cost of our materials very seriously. It's been a really tough year for the entire supply chain, both on getting materials, the cost of materials. So we take this very seriously and are working really hard at solutions for our direct customers and the end customers to keep costs down. not only the dollar per pound, but how it gets to them and how fast it can cure and how fast it can process and lower scrap rates. So there's a lot that goes into lower material costs. From the resins themselves, INEOS is bringing out some new products specifically designed to reduce the cost of the end product. Something we call the Aerotrain 800 series. You'll see some parts on display here. So this is mold in color, black, structural, UV stable resin system. So when you put it into your composite system, again, it doesn't need paint, and it's going to last a long time in the environment with really high mechanical properties. Another new product we're going to talk about more this week, something called Aerotrain 2502. It's a high performance hybrid resin system. The objective here is to get very high mechanical properties, strength specifically, using glass fibers instead of, I'll say it, carbon fibers. There's a lot of different ways to reinforcement, but certainly glass is one of the most economical. So this was a resin system, a matrix developed to try to maximize mechanical properties using traditional low-cost reinforcements. And then lastly, something we're calling the Aeropol Q Series, and this is really, we hope, is a win-win-win. It's a low-cost polyester, fairly good mechanical properties, but the third win is actually the feedstock resin is post-industrial recycled PET. So this is a step forward for thermoset composites, using a sustainable, renewable, recycled material as one of the key feedstocks, and it's lower cost than traditional polyesters. All right, well, again, I want to thank everybody. I think closing comments, the first statement qualifies for the overstatement or understatement of the year award. Certainly these are very challenging times for our industry and the automakers as a whole. A lot of trends, a lot of changes coming. So that really opens up the door right now for composites. Now is our window of opportunity to strike, to help the OEMs find solutions that are the lowest cost, utilizing, exploiting the advantages of composite materials. Certainly our mantra needs to continue to be educate, integrate, I was going to say vaccinate, so we can continue to do that. I think we continue to work together, and I certainly still feel that composites are still poised to take over the world with everybody's help at this conference. So thank you very much.
Thank you, Dan. We have a few minutes for a couple of questions. Any questions? Yeah, there's a question, Dan.
I'll weigh in. Sorry, Dan. I just want your opinion about how do you deal with buyers that are charged with taking price out, not cost. This is a battle I've fought for many, many years when I worked for LG. I had no problem convincing the engineers that composites were the right way to go. But the buyers were charged with taking X amount of dollars out of the part. How do you do that?
Ed, you're supposed to ask an easy question.
I thought that was easy.
Well, you know, certainly sometimes it's negotiation, sometimes you have to find ways that you can take cost out of the product so you can reduce the price. I mean, just dropping price is not good for anybody, but certainly, I mean, using some techniques, VAVE techniques, that's really analyze the part. I think it starts there. There's really some opportunity working with the customer to take cost out of the product, and if so, then you certainly can reduce the price as well. I mean, there's certainly severe situations where it's drop price or lose the business, and then companies have to make strategic decisions.
We have time for another question. Any questions? Yeah, there's one.
Is he a good fit for the lower volume EV market for composites versus the higher volume internal combustion engine?
Sure. Did you say the lower volume EV market?
Yeah.
Oh, yeah. Yeah, so the question was that composites fit in maybe this lower volume segment such as EVs. And Great question. I mean, think absolutely it's right in our sweet spot. You know, people have done these analysis of total costs, tooling divided by volume, plus variable cost, and composite materials usually look good right up through 60 to 80,000 units a year. So all these new entrants, all these new hybrids and EVs really are in our strike zone.
We can squeeze in one more question, last question.
Hey, Dan, how are you?
Morning.
As far as metal versus composites/plastics, the ongoing theme has always been the metal guys really get together and collaborate well relative to us. Now, I know we're doing things to do a better job, but what's your slant on that?
Did everyone hear the question? Okay, metal people have much organized operation, quote unquote, but the composites plastics community is less, paraphrasing the words, organized. What do you think?
You probably have a good opinion on that too. Yeah, it's a good question. It's a tough situation. So certainly, like from the design standpoint, it's a lot easier for designers and engineers to design with metal. They can open up a handbook and get properties and get material cards. We're not, I want to say fragmented, but each supplier really has what they think is the best formulation, best properties, and so maybe we're a little less open to sharing. But I think things like this conference, and there's groups like IACME and ACMA that are working together to try to get there, try to make it simpler for the automakers, designers, engineers to understand our materials and use them. So it's an area we have some work to do, but I think it started.
Thank you again for the nice presentation.